Completing the square. Why do we do completing the square? Well, sometimes we want to rewrite our equations and they're just not in the form that we want. Just like sometimes we want to simplify or our fractions. So what are perfect squares? Can anybody give me an example of a perfect square? Right. If you have a number that you take the square root, it's still a whole number. So for example, we just start with roots. 2 squared is 4, so 4 is a perfect square. 6 squared is 36, so 36 is a perfect square. It's perfect because we don't have to deal with decimals, I guess. Perfect. All right, so these are the squares that we're talking about when we want to complete the square for our equations. So let's start with this. A plus b squared. If I were to square this out, or FOIL this out, I would get a squared, and then the inner, these multiply to each other twice, so it's actually 2ab, and then the b squares. So what we're doing is we're taking this part and we're trying to make it look like a perfect square. So we have something that we have to adjust. So for example, and I want to just stick with equations because that's pretty much all the applications that we're going to do. If I have x squared plus 4x equals 0, and I want to complete the square here, the first thing that I want to do is I'm going to half this linear term. Now if I half this linear term, and I want to just make a little note, x plus 2 squared, it's actually equal to, just like here, square the x. This gets multiplied by itself twice. That's why we take half. And then we have this extra part. This 2 times 2 is 4. So if I want to complete the square here, notice that this equation is 4 more than that one. So I just add 4 to both sides. Actually, I'm just adding it to the right because I add it to the left when I write it in the binomial squared. Okay, so let's recap the steps when we do the perfect square. We're going to first half the linear term. And then we're going to add the square to the right side. Okay, so let's do another example real quick. I don't like that example. Let me look at one of yours. Between 1 and 3, which one do you like for an example? 3? Okay, so we'll do number 3 as an example. Now this, of course, has x and y. So number 3 has x squared plus y squared minus 12x minus 8y equals negative 20. Okay, so I have my equation. I want to make a perfect square on the left, and then I'm going to add whatever I've added into. I need to make sure I add it to the right side as well. So here we're going to group So x squared minus 12x, those are together. And then y squared minus 8y is together. Okay, our step 1. So I'm going to take half the linear term. So I have x minus 6 squared plus y minus 4 squared equals. So I start with negative 20. What is negative 6 squared? 36. And it's always positive because we're squaring the sign as well. So we're going to add 36. And then what is 4 squared? So we're going to add 16 as well. So I have x minus 6 squared plus y minus 4 squared. And when I combine these, see, that takes 20 away from that. 16 plus 16 is 32. Okay. So what this means, I know it's asking for the standard equation, so that's what the standard equation is there for number 3. The center, you just read off, is 6 and 4. Remember, you subtract your coordinates. And then the radius is going to be the square root of 32. Can you simplify that? Does 32 have a factor that's a perfect square? What is it? There's another one. Isn't it 16? Okay. So remember, 32 is 16 times 2. So the square root of 32 is the square root of 16 times 2. What's the square root of 16?
4.
Okay.
4.
There you go. And that is it.